Hello, this video is for lesson 1 of chapter 3, so we're doing lesson 3.1. This lesson is titled Solving Two-Step Equations, where we'll solve two-step equations. Our review vocabulary is verbal model, equation, and inverse operations. So in the past we've done one-step equations where all you had to do was do one step. That was you were either adding or subtracting something, or you were multiplying or dividing something in order to get the solution. Now we're going to be doing two steps where we're going to be doing a combination of addition, subtraction, along with multiplication or division. So in our example here, it has drum set. You're buying a drum set that costs $495. The music store lets you make a down payment. You can pay the remaining cost in 3 equal monthly payments with no interest charged. You make a down payment of $150. How much is each monthly payment? Well, in example 4, you'll see how to answer this question by writing and solving a two-step equation. So you can solve a two-step equation by using two inverse operations, and we learned what inverse operations were in previous lessons. That is to say that addition and subtraction are inverse operations to each other, and likewise multiplication and division are inverse operations to one another. So we're going to undo addition with subtraction and subtraction with addition, and we're going to undo multiplication with division, and we're going to undo division with multiplication. So let's take a look at our first example here. In example 1, we're going to be using subtraction and division to solve this equation that we see here, 3x plus 7 equals -5. And then we're also going to check our solution. We see the check down here at this point. So it says 3x plus 7 equals -5. Well, let's go back and think about order of operations, PEMDAS. Parentheses, then we do exponents, then we do multiplication and division, and then we do addition and subtraction. So we would do these in order going from left to right whenever we work out a problem, just like this one down here follows the order of that. First we have to do the multiplication of 3 times -4, and then add the 7. Well, whenever we're solving something, we kind of have to do the reverse order. We're going to go from the right going to the left. And this makes sense because if you think about it, if you're putting something together, like say, I don't know, you buy a new table and chair set, a new dining set, it usually doesn't come assembled. You have to put the legs on the table and the legs on the chairs, and you have to do some nuts and bolts and put stuff together. And so you buy a table and you put it together. You decide that you're moving, and in order to fit it in the moving truck better, you have to take it apart. Well, you're going to take it apart pretty much in the opposite order that you put it together in. So we're going to have to deal with the addition and subtraction first, and then do multiplication and division. And if we had exponents, which we're not going to see exponents here, you'd have to do that. So we're going to do this pretty much in reverse order. So remember that whenever we solve an equation, the object, whenever we say that we're solving an equation, the object is to isolate the variable. And isolate means all by itself. If you were stuck in isolated on a desert island, you would be by yourself pretty much. So the idea is to isolate the variable and get it all by itself, and then where it actually has a value that it's equal to. So before we can deal with the 3 being tied to the x with multiplication, we have to first deal with this plus 7 that's tied to the 3x. So the opposite operation of addition is subtraction. We're subtracting the very value we wish to get rid of, which is 7. And what we do to one side, we have to do to the other. So we are subtracting 7 from both sides. Whenever we do that, we see that these are opposites. So +7 and -7 is going to equal 0. Leaving us just with this 3x that we see here. And then 5 minus 7, which is the same as 5 plus -7. So we're going to add those values together and get 12. And since they're both negative, it would be negative itself. So we end up with 3x equals -12. Now we have to do the second step. That is to deal with this multiplication. The 3 is tied to the x through multiplication. The opposite operation is division. So we're going to use a fraction because all fractions are division problems. And we're going to divide by the very number we wish to get rid of, which is 3. So we're going to divide 3x by 3. And what we do to one side, we have to do to the other side. So -12 divided by 3. Here the 3 is going to cancel each other, and we get x, and negative 12 divided by 3 is negative 4, because this is a negative being divided by a positive. So since they are different signs, our product, the answer there, is going to be negative, and 12 divided by 3 is indeed 4. We can check this solution by plugging it, or we can check this equation, or check our solution by plugging it back into the equation and evaluating it. So we just plug in the 4 here. 3 times negative 4 is negative 12, plus 7 is going to be negative 5, and indeed we bring that negative 5 down, and we see that negative 5 is indeed equal to negative 5, so our solution checks out. So again, just like we do PEMDAS to put it together, to take it apart, we're going to go in the reverse order and do the addition and subtraction first, followed by the multiplication and the division. So let's check a couple of these out. Let's do the 4x plus 1 equals 5. Well, the 4x is tied to the 1 through addition. The opposite operation is subtraction. We're going to subtract the very value we wish to get rid of, and what we do to one side, we're going to do to the other. After we do that, these are opposites. The ones are going to cancel each other, leaving us with just 4x, and then we're going to end up with 5 minus 1 is 4. Now the 4 is tied to the x through multiplication. The opposite operation is division, which is a fraction, and we're going to divide by the very number we wish to get rid of, which is 4. What we do to one side, we do to the other. Now the 4's will cancel each other, leaving us with just x, and 4 divided by 4 equals 1. We could plug that back in and say 4 times 1 is 4, plus 1 equals 5, so we know that our solution is correct. Let's go ahead and pick another one here. Let's do maybe problem number 3. 1 equals 2r plus 9. So before we can deal with the multiplication between the 2 and the r, we have to first deal with this plus 9. So it is addition. We're going to use the opposite operation, which is subtraction. We're going to subtract the very number we wish to get rid of, which is 9. And what we do to one side, we have to do to the other. So we are subtracting 9 from each side. The positive 9 and negative 9 are going to cancel each other out because they are opposites, leaving us with just 2r on the right. Now we have 1 minus 9. So if we took 9 away from 1, we would get negative 8. Now we can deal with the multiplication between the r and the 2. The operation that's connecting them is multiplication. The opposite operation is division, so we're going to use a fraction. We're going to divide by the very number we wish to get rid of, and what we do to one side, we're going to do to the other. These 2's are going to cancel each other, leaving us with just r. And negative divided by a positive is going to be a negative. And 8 divided by 2 is 4, so r equals negative 4. If we plug that back in up here, and we did 2 times negative 4, is going to give us a negative 8, and then we add 9, well, that's going to go ahead and produce for us a value of 1, and sure enough, 1 equals 1, so we know that our solution is correct. Looking at the next one, example 2, we're going to use addition and multiplication to solve. So we start off with x over 2 minus 3 equals 1, or this is x divided by 2, correct? So the operation is division. But before we can go ahead and get rid of the 2 that's tied to the x, we first have to deal with this minus 3. So the 3 is tied to the x over 2 by subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is the 3. And what we do to one side, we're going to do to the other. So these are opposites. Negative 3 and positive 3 is going to produce a value of 0, leaving us with just x over 2. And 1 plus 3 is 4. Now the x and the 2 are related to each other through division. The opposite operation is multiplication, and we're going to multiply by the very number we wish to get rid of, which is 2. So we see that we're multiplying x over 2 by 2, and what we do to one side, we have to do to the other. The 2's are going to cancel each other out, leaving us with just the x, and 2 times 4 is 8. So we end up with the solution is x equals 8. So let's go ahead and check that out, plug that back in. So we plug in the 8. Now we have to do multiplication and division before we do addition and subtraction. So we have to do the 8 divided by 2 is 4. 4 minus 3 is 1. 1 equals 1, so indeed the solution checks out. So let's look at a couple examples here. Let's do, this time we'll do 7 and 9. Let's give those a try. So we have c over 6 minus 2 equals 6. So before we can deal with the c over 6 part, we have to deal with this minus 2. So it is subtraction, so the opposite operation is addition. And we're going to add the very number we wish to get rid of, which is 2. And what we do to one side, we have to do to the other. So we end up with c over 6, because these are going to cancel each other, and 6 plus 2 equals 8. Next, we have to consider the relationship between the c and the 6. Well, it's a fraction, so it's division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. The 6's are going to cancel each other, leaving us with just c. And 8 times 6 is indeed 48. Now, we plug that 48 in up here. We would have 48 divided by 6 is 8. Then we subtract 2, and that equals 6. Indeed, it checks out, so we know that we have the correct answer. Let's go ahead and look at number 9 right here. We have 12 equals f over 2 minus 8. So before we can deal with the division between the f and the 2, we have to deal with this minus 8. So the opposite operation of subtraction is addition. We're going to add the very number we wish to get rid of, which is 8. And what we do to one side, we need to do to the other. After we do that, the 8's will cancel each other out, leaving us with f over 2. And 12 plus 8 is 20. Now, we have to go ahead and deal with this relationship of division between the f and the 2. So we're going to go ahead and multiply, which is the opposite operation of division. We're going to multiply by the very number we wish to get rid of, which is 2. And what we do to one side, we're going to do to the other. The 2's will cancel each other, leaving us with f. And 2 times 20 is 40. So f equals 40. So if we put 40 in here, substitute it back in to check our answer, 40 divided by 2 is 20. Then we subtract 8, and that equals 12. 12 and 12 do equal each other, so we know that indeed 40 equals f, or if you want, f equals 40. I kind of like the variables on the left. So f equals 40 is the correct solution. So here we have an example where we're solving an equation with negative coefficients. Remember, coefficient is that number that sits out in front of the variable. So this is a variable y. In front of it's a 4, but this is actually a negative 4. And if you're like, well, it looks like it's just 7 minus 4, it's actually 7 plus negative 4y equals 19. We could rewrite it that way, just changing this to a sum instead of a difference, right? And we see that the number that is in front of the variable, the coefficient, that is a negative value. So let's go ahead and look and see what they do here. We have to first get rid of this positive 7. So we're going to add a negative 7 to each side, because before we can deal with that multiplication that's going on between the negative 4 and the y, we first have to get rid of that 7. So we're subtracting 7 from each side. The 7's will cancel each other, leaving us with just negative 4y. And 19 minus 7 is 12. Now the y is tied to the negative 4 through multiplication. The opposite operation is division using a fraction. We're going to divide by the very number we wish to get rid of, which is the coefficient of negative 4. So divide by negative 4. And what we do to one side, we are doing to the other. The negative 4 is going to cancel each other, leaving us with just y. And 12 divided by negative 4, well, it is a positive divided by a negative, so the answer is going to be negative. And 12 divided by 4 is 3, so our solution is negative 3. And then we see that once we plug that in, indeed it checks out to be the correct solution. So using our checkpoint here, we'll go ahead and we'll do number 11 right here. So let's go ahead and write this as a sum instead of a difference. Let's do 6, change the subtraction to addition, take the opposite of the value that follows. So instead of positive 2m, it's a negative 2m equals 8. Doing so lets us see that this is definitely a negative coefficient that we have tied to the variable m. So let's get rid of the 6 right here. Let's subtract 6, right? So subtract 6 from each side. What we do to one side, we do to the other. The 6's are going to cancel each other, leaving us with the negative 2m. And that equals, well, 8 minus 6 is 2. Now, the negative 2 and the m are tied through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, which is negative 2. And what we do to one side, we are going to do to the other. The negative 2's are going to cancel each other, leaving us with just the m. And positive divided by negative is going to equal a negative. And 2 divided by 2 is 1. So m equals negative 1. So that brings us to example 4 with our drum purchase. Right, so we're purchasing the drums for, remember, $495, and we're making a down payment of $150, and then we can make 3 equal payments on the remaining amount over 3 months, right? So we're going to let P represent our monthly payment, and we're going to write a verbal model. So remember, the question was, what is your monthly payment? So we're going to take the total cost of the drums, and the total cost of the drums is equal to the amount of your down payment plus all of your other payments. And remember, your payments are going to be the number of months and what your monthly payment is. Well, they've given us all the information except for what our monthly payment is. So let's plug in what we have. The total cost of drums is $495. The amount of our down payment was $150. The number of months that we are paying on this is 3 months. And what we don't know is what our monthly payment is. That's going to be represented by the value or the variable P. So we first need to get rid of this 150 here because it's tied to the 3P, right? So it is a positive 150, so we're going to subtract 150. These, and what we do to one side, we're going to do to the other, so we're going to subtract 150 on the left as well. The 150 and the negative 150 are going to cancel each other out, leaving us with just 3P. So that's where we're getting this 3P here. 495 minus 150 is 345. Now the 3 is tied to the P through multiplication, so we're going to use division. And we're going to divide by the very number we wish to get rid of, which is 3, right? And what we do to one side, we are going to do to the other side as well. So we're dividing both sides by 3. The 3's are going to cancel each other, leaving us with just P. And 345 divided by 3 is 115. So our monthly payment is $115. That brings us to our guided practice. You can use 2 blank operations to solve a 2-step equation. Well, this answer would be 2 inverse operations. I know I often say the opposite operation is, and by opposite I mean the inverse operation. Describe the steps you would use to solve the equation 9 plus 2s equals 15. Well, first we had to get rid of this 9 before we could deal with this multiplication here between 2 and s. So first I would subtract 9 from each side, and then I would divide by 2. Subtraction to get rid of the negative, or subtraction to get rid of the positive 9, and then division to undo the multiplication between the 2 and the s. Let's do a skill check here. Let's solve the equation, and also it says to check our solution. Let's go ahead and do number 6 down here. Number 6. So I'm going to have negative 8, and I'm going to change this subtraction right here to addition, and then take the opposite of the next value here. So instead of positive 8d, it's going to be negative 8d. So we see that indeed we have a negative coefficient there, equals 64. So let's first add 8 to get rid of this negative 8 here. And what we do to one side, we're going to do to the other. And so we're going to end up with negative 8d equals, and 64 plus 8 is going to be, what is that, 72, right? Now we need to divide both sides. We're going to divide because the negative 8 is tied to the d through multiplication. The opposite operation is division, so we're going to divide. We're going to divide by the very number we wish to get rid of, which is negative 8. And what we do to one side, we are going to do to the other. The 8's are going to cancel each other, leaving us with just d. And positive divided by negative is negative. 72 divided by 8 is 9. So 9 is our solution. Now we could go back and plug that in and check that out and see. So if we had negative 8, and let's go ahead and do it up here. take what we have right here. What I'm saying is, let's take this negative 8, change the sign. Negative 8, the coefficient is negative, right? We can see that here. Change that from a difference to a sum. Plug in what we have for D, which is negative 9, and that's supposed to equal 64. So let's take negative 8. We need, through PEMDAS, says we have to do our multiplication and division first. So negative 8 plus, and then negative 8 times negative 9. Negative times negative is positive. 8 times 9 is 72. Bring down to 64. Now, negative 8 plus 72. This is the sum of a positive and a negative, so we know we actually have to subtract the lower absolute value from the greater absolute value. So we're going to have 72 minus 8 is 64. And since 72 has a greater absolute value than negative 8, we're going to use the sign that matches the 72. So 72 is positive, so our 64 is going to be positive. Bring down our 64 there, and indeed, that checks out. We're good to go. All right, I think I'm going to skip the car repair for right now. And if you want, you could pause it, look over it if you'd like. But I think I'm going to go ahead and pass over that for now. I think we're pretty much good to go. So that's all of my instruction for Lesson 3.1, solving two-step equations. Thank you.